Now, fifth question, children. Sinu's house has an overhead tank in the shape of the cylinder. This is filled by pumping water from the sump, underground tank, that is called a sump, which is in the shape of the cuboid. The sump has dimensions 2 meter into 1.5 meter into 1 meter. The overhead tank has its radius of 60 centimeter and height 105 centimeter. Find the volume of the water left in the sump after the overhead tank has been completely filled with water from the sump, which has been full initially. Initially means beginning. In the beginning, the sump has full water. From the sump, that is from the underground tank, they are taking the filling the overhead tank, which is in the shape of the cylinder. Understand? Now, the underground tank is in the shape of the cuboid. The dimension of the cuboid is given, that is LBH is given. Then the overhead tank is in the shape of the cylinder. So radius of the cylinder and height of the cylinder is given. Understand, children? Now what we have to do? We have to equate the volume. The volume of the, now they ask you to find out the volume of the water left in the sump. In the beginning, the sump was with full water, no. Now some water was filled in the overhead tank from the sump. So now the overhead tank was filled with the water. So what will happen? Remaining, there is some water in the sump. So now we want to find out the remaining water in the sump. Solution: cylindrical overhead tank and cuboidal sump. These are the two shapes we have to discuss here. Cylindrical tank, radius is given as 60 meter. Cuboidal sump, length is given as 2 meter. Convert into centimeter. So 200, 1 meter equal to 100 centimeter. So 2 meter equal to 2 into 100, 200 centimeter. Then height of the cylindrical tank is given, h equal to 105 centimeter. Breadth of the cuboidal sump is given as 1.5 meter. Convert into centimeter. If you multiply, you will get 1500. Then you have to put decimal point. So 10 will get cancelled. 150 centimeter. Height of the cuboidal sump, h equal to 1 meter, that is 100 centimeter. See here, children, I fixed the radius and height of the cylindrical overhead tank as small r and small h, and I fixed the length, breadth and height of the cuboidal sump as capital L, capital B, capital H. Now we want to find out the volume of the water left in the sump. How to find out? Volume of the water initially in the sump minus volume of the water pumped in the overhead tank. From the sump, some water was pumped into the overhead cylindrical tank. So remaining water we want to find out. So you have to first find out the volume of the water initially in the sump. Initially means beginning. From that we want to subtract the water which was pumped into the overhead tank. If you subtract that volume, you will get the remaining volume of the water that is left in the sump. Am I correct, children? Volume of the water initially in the sump. It is in the cuboidal shape. So what is the formula to find out the volume of the cuboid? L into B into H. Then volume of the water pumped in the overhead tank. How to find out the volume of the cylindrical tank? Using the cylinder formula. What is the formula to find out the volume of the cylinder? Pi r square H. So substitute the formula. Write the formula. Now you substitute the values. L value 200, breadth value 150, H value 100, minus pi value 22 by 7, r square, r value 60, so 60 into 60, H value 105. We have to cancel 7 and 105. Yes, how many times? 15 times. 7 ones are 7, 7 15s are 105. Now 200 into 150 into 100, if you multiply, you will get a 30 lakhs minus 22 into 60 into 60 into 15. If you multiply, what you will get? 11 lakh 88,000. Subtract it. 18 lakh 12,000. centimeter cube. Remaining volume of water in the sump equal to 18 lakh 12 lakh centimeter cube. Are you able to understand the sum, children? Volume of the water left in the sump we want to find out. First we want to find out the volume of the water initially in the sump. Then some water was now pumped into the overhead tank, that is cylindrical tank. So how much water was pumped? That volume we want to subtract. So if you subtract, you will get the volume of the remaining water in the sump.